Hi guys, I'm Fakhra Hashmi, your physics teacher. Hopefully we got all the ingredients of the kinematics lecture in the previous two parts. If you didn't watch all those parts, so just go to the description box and just watch all those parts. We got all the ingredients in the previous two parts, so just we are going to start the last part of kinematics. So let's start.
So one important thing that we must have to consider in kinematics is the falling objects. So if your objects are going to be false, so what would be the parameters and what would be the conclusion that can be drawn for the kinematical objects and what was the physics behind it. So let's start. We have already learned that your average velocity can be written as your initial velocity and final velocity addition divided by 2. So if your initial velocity is 0, so your acceleration is going to be considered to be constant. So then V final can be written like this: 2 of average of velocity. This is 0. This can be written as 2 times of average velocity. And again, the acceleration can be written as change of velocity with respect to your time. So change in velocity final minus initial divided by time. So we just have to use the average velocity concept to find the average velocity, and then we have to find out the final speed of your object. Like this is the marble, so calculate the expression of the marble. This is so easy. So a free fall is when an object is moving under the influence of your gravity. Only gravitation force is going to change the motion of your object. So in a vacuum, all objects fall at the same acceleration. So g is equal to 9.80 meter per second squared down. And if an object is going to be thrown up, down, or dropped, then this should have this magnitude acceleration. So falling objects, you can drop a coin from the top of the 100-story building, like 1,000 meters if the distance of that building, or height of that distance, or height of that building. So if you ignore the air resistance, then how fast will it be falling right before it hits the ground? So you have data like it is moving from rest. So V naught is equal to 0, and final velocity we have to find out final velocity. Then acceleration, that is because you are going to throw it from upward to downward. So acceleration, we have taken acceleration as negative of acceleration. It all depends upon your convention. And then the height of that tower or the building is 1,000 meter, and the initial distance was 0 meter. So you just have to put the values in your third equation of motion to get the value of final velocity. That's all. So how long does it take to hit the ground? So you just have to find out the distance. So you are probably going to ask to use second equation of motion. Just have to put the values and to get the time. So again, if a baseball is hit straight up into the air, if the initial velocity is given, then how high will the ball is going to go? So you have to find out the distance. So this is the possible data. You just have to put the value, all the values in third equation of motion to get the value of your distance. That is 20.4 meter height. Again, you are going to ask how long will it be? Until the catcher catches the ball at the same height it was hit? So you're going to ask about the time. So you're just going to put all the values in second equation of motion to get the time. So again, how fast is it going when catcher catches it? So you're just going to ask about the time. So this is going to be done with the help of third equation of motion like this. So now we are going to start the two-dimensional vectors. So this is the vector. It has some tail and it has some arrow. So anything that has some arrow and head can be represented as a vector in graphical notation. So vectors are those physical quantities that should have magnitude as well as its direction. So they are represented by arrows like this shown in the figure. And the length of the arrow is your magnitude, but the arrow pointed out would give you the direction of that particular vector. So the two-dimensional vectors can be written like this. If you are going to draw a vector in xy plane, so this could look like this. It is making an angle theta with your positive x-axis. So you just have to draw some projection from that particular arrowhead. So the horizontal component would give you the x component of that vector, and the vertical component give you the y component of that vector. So this is again the right angle triangle law that is going to use the vector as hypotenuse. So we can use sine and cosine to get the values of horizontal and vertical components. So if your vector is running in opposite direction, you just have to put negative sign over it. So this is the sine, cosine, and tangent formula. So the two-dimensional vectors can be represented by this example. Like if you're a football player, kicks a ball at 15 meter per second at 30 degree above the ground. Find the horizontal and vertical components. Just have to put the velocity magnitude as 15 meter per second. So if horizontal is asked, then 15 times cosine of theta, that is 30 degrees. So this would give you 13 meter per second. And if I'm going to calculate the vertical component, so this would be 15 times sine of 30. That would give me 7.5 meter per second square, 7.5 meter per second. So if your velocity is like this, and this is half of your velocity, and this is double of your velocity, there's the same magnitude and direction is same. So this is the half of velocity because your vector is going to be get in half in its length, and this is negative v. It has the same magnitude but opposite in direction. So vectors can be multiplied with the scalar number. It is just going to have the greater magnitude, but direction would be same. So yeah, this all can be done like this. So the two-dimensional vectors can be added, like if one vector is going to be added into second, like the next vector's tail is going to be put over this first vector's head, then third vector that is going to be added should be put over the head of your second vector. Then finally you will get like this. So head to tail rule, what head to tail rule would give us the resultant? Basically you just have to draw the resultant tail from first vector and join the resultant head with the last vector added. So this would be my resultant vector. So this is the graphical method. So you can see the steps over here. Fine. So I can also draw it on the graph paper like this. If A is vector 2, square root of 2 at 45 degree of east, north of east, and then B vector has magnitude 2, square root of 2 at 45 west of north. So this can be drawn like this. Then we have the two-dimensional vectors like this. A vector is going to be added over the second vector, then resultant would be like this. C, tail to tail and head to head to head. So A vector components Ax and Ay. B vector components can be written as B of x and B of y. So if I'm going to ask for the horizontal and vertical component of C vector, so that would be the Ax plus Bx and Ay plus By. This would be my resultant vectors of C vectors. So yeah, I missed that. So this is the component method. You can see all the steps with the help of figure. You can also find out the direction with the tangent inverse. Like if someone going to ask about the direction of C vector, so I'm just going to get the tangent of theta is equal to my perpendicular over base. My perpendicular is Ay plus By, and my horizontal is Ax plus Bx. So I'm just going to divide all these equations and then get tangent inverse. So I'll get the direction. So on which coordinate C is going to be lying. So this is the again the example. C vector is given, D vector is given with some angle. So C vector is given and D vector is given, and I've just put the values with the help of the north, west, east, south direction. So this could look like this. So C horizontal component and vertical component can be calculated like this. D horizontal and vertical component can be calculated like this, and then finally we can get simply addition of Cx and Dx and simply addition of Cy and Dy. So we'll get the resultant horizontal and vertical component. This is again an example. You can do it by your own, so it would be much easier. Thank you so much for your interest in the kinematical topic.